Good afternoon, everyone. I hope you all are doing well today. First of all, thank you for joining this session. Let me introduce myself. I am Komati A. I am a faculty of Physics, School of Maritime Studies. I have a deep interest to teaching and simplifying physics concepts for students, especially for competitive exams like IMUCET. Physics is often seen as a difficult subject, but in reality, it becomes very easy when we understand the concepts clearly. It is not about memorizing formulas, but about knowing why and how things happen. In IMUCET, physics plays a very important role, and questions are mostly based on concepts, applications, and problem solving skills. So, in this class, we will focus on some questions based on the IMUCET physics syllabus. Let's start discuss now. Our first question is, a body is moving along a circular path of radius r with velocity v. It has a centripetal acceleration a. Its velocity made equal to 2v. Then its centripetal acceleration is dash. You just consider a body. It is moving along a circular path. Its radius is r and velocity is v. The centripetal acceleration a is equal to v square by r. The second system is its velocity is made equal to 2v. So we just consider as v is equal to 2v. Now we are going to find out the centripetal acceleration. This new system centripetal acceleration we just consider as a2. So a2 is equal to v square by r square. Now we are going to find out the ratio between the a1 and a2. So v square by r square divided by 2v whole square by r square. If we are cancelling this v square, a2 is equal to 4a1. So the answer is 4a, option A. The second question is, the angular velocity of a second hand of a clock is. What is angular velocity? Angular velocity is defined as rate of change of angular displacement. Angular displacement per time. The second hand of a clock completes one rotation in 1 minute, which means 60 seconds. So the angular speed which is equal to angular swept by radius vector by time taken. Angle swept for one complete rotation is 2 pi radiation. So we can write angular velocity equal to 2 pi divided by 60. So the answer is option C, pi by 30. The next question is, a body is moving in a circular path with acceleration is a. If its velocity gets doubled, which means 2v, find the ratio of acceleration after and before the change. We just consider before the change, the acceleration is equal to a1. After the change, the centripetal acceleration is equal to a2. The formula of centripetal acceleration a is equal to v square by r. Now we are going to find out the ratio of acceleration after and before the change. So a2 square by a square by a1 square is equal to 4. The ratio of after and before the change of acceleration is equal to 1:4. Next question is, a cyclist is traveling with a velocity v on a radius 20 meter. If the coefficient of friction is 0.64, the coefficient of friction, which means mu, then the maximum velocity with which can move is. In this problem, we need to find out the maximum velocity. A cyclist is traveling with a velocity v on a radius r is equal to 20 meter. The coefficient of friction mu is equal to 0.64. Now we are going to find the velocity, maximum velocity v. The formula of maximum velocity is equal to root of mu r g. Mu represents coefficient of friction. It was given in the problem 0.64. Then r represents the radius. R is equal to 20 meter. Then g. G is the gravitational constant. G is equal to 9.8. Now we are going to substitute these values r, mu and g in the above formula. V is equal to root of 0.64 into 20 into 9.8. So the answer is 11.2 meter per second. The next question is, the bending of beam of light around corners of obstacles is called diffraction. Bending of light around edges or obstacles, which is called as diffraction. Then bouncing back from a surface, which is called as reflection. Bending when passing through different media, which is called as refraction. Then restricting vibrations to one plane, it is called as polarization. The next question is, the amplitude ratio of two superposing waves is 2:1. The ratio of maximum and minimum intensity is. The formula of maximum and minimum intensity is given by I maximum divided by I minimum, which is equal to A plus B whole square divided by A minus B whole square. Here A is equal to 2, B is equal to 1. So we can write I maximum divided by I minimum is equal to 2 plus 1 whole square divided by 2 minus 1 whole square. 2 plus 1, which means 3 whole square 9. 2 minus 1, which means 1. 1 square 1. So the answer is 9:1. The ratio of maximum and minimum intensity is 9:1. Next question. A double slit interference experiment is carried out in air and the entire arrangement is dipped in water. So the fringe width is increases, or option B decreases. Option C is remains unchanged. Option D is fringe pattern disappears. The answer is the fringe width is decreases. Next question is, two pin lengths of focal length F1 and F2. It is placed coaxially in contact. The combination acts as a single length of focal length. Focal length 1 by F is equal to 1 by F1 plus 1 by F2. We can write in the next step 1 by F is equal to F2 plus F1 divided by F1 into F2. Then we need the focal length F is equal to, we can write F1 F2 divided by F1 plus F2. The next problem is, the speed of light in air is 3 into 10 power 8 meter second minus 1. What will be its speed in diamond whose refractive index is 2.4? The formula is equal, V is equal to C by N. C is equal to 3 into 10 power 8. Then refractive index is equal to 2.4. So V is equal to 3 into 10 power 8 meter second minus 1 divided by 2.4. If we solve the above equation, the result is V is equal to 1.25 into 10 power 8 meter per second. A semiconductor is cooled from T1K to T2K. What will be the resistance? When a semiconductor is cooled, it acts as an insulator. When a metal is cooled, it acts as a conductor. Cooling a semiconductor makes it more like an insulator, so its resistance will be increased and then conductivity will be decreased. Always resistance is inversely proportional to the conductance. Our next question is, what is the relation between the frequency and time period? Frequency means F and then time period T. F is inversely proportional to the time. So we can write F is equal to 1 by T. This is the relation between the frequency and time period. Our next question is, according to Newton's law of gravitation, F is directly proportional to M1 and M2. This is option A. And option B is F is directly proportional to 1 by R square. Option C is both A and B. Option D is none of this. What is Newton's law of gravitation? What it defines means the force which is directly proportional to the product of the masses of two bodies, which means M1 and M2, and the force is indirectly proportional to the square of the distance between the two bodies, which means F is indirectly proportional to the square of the distance between the two bodies R square. So we can write F is equal to M1 into M2, product of the two masses M1 into M2 divided by inversely proportional to the square of the distance between the two bodies R square. So F is directly proportional to M1, M2 divided by R square. The answer is option C, both A and B. Next question is, two charges, 2 microcoulomb and 8 microcoulomb. It is separated by a distance 2 meter. What is the force? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the Newton's gravitational force. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Q1 Q2 means two charges. Q1 is equal to 2 microcoulomb. We can write 2 into 10 power minus 6. Then Q2 is equal to 8 microcoulomb. 8 into 10 power minus 6. So we are going to substitute these Q values and then R is equal to 2 in the above equation. F is equal to 1 by 4 pi epsilon naught value is 9 into 10 power 9. So 9 into 10 power 9 into 2 into 10 power minus 6 into 8 into 10 power minus 6 divided by 2 square. R is equal to 2. So we can write 2 square 4. If we solve this above equation, finally we get the result 0.036 Newton. This is the answer. The next question is, two charges Q1 is equal to 5 microcoulomb, Q2 is equal to 10 microcoulomb, which is placed 0.5 meter apart in a medium of Dielectric constant 4. What is the force? Dielectric constant, which means K value. K is equal to 4. Two charges Q1 is equal to 5 microcoulomb. Q2 is equal to 10 microcoulomb. What is the formula for this? Newton's gravitational force F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So F is equal to, what is the value of 1 by 4 pi epsilon naught? 9 into 10 power 9 into 5 into 10 power minus 6. Then Q2 value 10 into 10 power minus 6 divided by K. Dielectric constant value is 4. So 4. So the final result is F is equal to 0.45 Newton. Next question is, two charges plus Q and plus 4Q are placed at a distance D. Where should be third charge be placed? So that net force is 0. Let point be a distance x from plus q. We can write kq divided by x square is equal to k into q, which means 4q. So the distance we can write d minus x whole square. So this k and q will be cancelled. In the second step, we can write 1 by x square is equal to 4 by d minus x whole square. So 1 by x we are going to find out now. 1 by x is equal to 2 by d minus x. So from this equation, we can found the value of d minus x. So d minus x is equal to 2x. So x is equal to d by 3. So what is the answer means? Option C, d by 3 from plus q. Now next question is, two capacitors, 2 microfarad and 3 microfarad, which is connected in the series. We need to find out the equivalent capacitance. The formula of equivalent capacitance is equal to 1 by C. You just listen, these two capacitors are connected in the series connection. So the formula of equivalent capacitance is equal to 1 by Cs is equal to 1 by C1 plus 1 by C2. 1 by 2 plus 1 by 3. C is equal to 1 by C is equal to 5 by 6. C is equal to 6 by 5. If we short out this 6 by 5, we got 1 by 2 microfarad. Our next question is, two charges plus Q and plus 4Q are placed at a distance D. There should be a third charge be placed so that net force is 0. Let point be at distance x from plus Q. Kq by x square is equal to k into, what is the Q value? 4Q divided by d minus x whole square. K and Q will be cancelled. We can write 1 by x square equal to 4 by d minus x whole square. 1 by x is equal to 2 by d minus x. From this equation, we can find d minus x. D minus x is equal to 2x. So, x is equal to d by 3. The option is C. Next question is, an intrinsic semiconductor at 0 Kelvin temperature behaves like, when the semiconducting materials is cooled or reducing the temperature or at 0 Kelvin temperature, it behaves like an insulator. An intrinsic semiconductor at 0 Kelvin has No free charge carriers. Charge carriers is nothing but electrons and holes. The electrons are stayed in the valence band and holes are in the conduction band. Our next question is wire length is double, radius is half. What will be the resistance change? We just consider a length of wire. That wire length is L. Okay, then the radius is R. The area of cross section of the wire is equal to A is equal to pi R square. The resistance formula is R is equal to rho into L by A. L means length of the wire, A represents the area of the wire, rho represents the resistivity of the wire. Okay. Then A, the area of cross section A is equal to pi R square. Now the wire length is doubled. So the new length is equal to 2L. The radius is half. The radius R is equal to R by 2. Okay, what will be the resistance? R dash. R dash is equal to rho into L by L is equal to 2L here. Why? Because the wire length is doubled. So 2L by pi R, R by 2 whole square. Because the radius is half. So R by 2 used here. We are going to find out the ratio of R dash by R. R dash is equal to 8 into R. So the resistance change is 8 into option D, 8. Our next question is NAND gate is basic gate, universal gate. Option C is NOT gate. Option D is OR gate. NAND gate and NOR gate is called as universal gate because it can construct any logic circuits. Okay. Then AND gate, OR gate and NOR gates are called as basic gates. A NOR gate has only one input and one output. The input is A and then output is A bar. 1 means 0, 0 means 1. And then OR gate. It has two inputs A and B. The output is Y is equal to A plus B. Then AND gate. It also has two inputs A and B and then the output Y is equal to A dot B. The next question is Hall voltage is proportional to dash. Hall voltage, which means VH, is directly proportional to the magnetic field B and current I. So we can write VH is directly proportional to BI. The option A is current, option B is magnetic field, option C is both, option D is none. The option is C, current and magnetic field. Hall voltage is directly proportional to BH is directly proportional to B and I, magnetic field and current. If temperature increases, intrinsic carrier concentration is increases exponentially because Ni is directly proportional to e power minus Eg by 2 kT. It increases rapidly with temperature. In intrinsic semiconductor at 0 Kelvin, an intrinsic semiconductor at absolute zero behaves as an insulator. At 0 Kelvin, there is no thermal energy, no free electrons and holes, no charge carriers, and then there is no conduction. So the intrinsic semiconductor at 0 Kelvin, it behaves as an insulator. In p-type semiconductor, holes are the majority charge carriers. It has trivalent doping creates holes as majority carriers. If we are doped with the p-type semiconductors, the material should be in 3 valence electron, should have 3 valence electrons and trivalent bond materials. Next question is doping in semiconductor. What is doping? Adding an impurities with a pure material which is called as doping. Adding pentavalent impurity produces option A is p-type semiconductor, option B is n-type semiconductor, option C is intrinsic semiconductor, option D is insulator. Option B is the correct answer, n-type semiconductor. Because n-type semiconductor has pentavalent impurity, it has 5 valence electrons. So this kind of the materials is doped with the pentavalent impurities materials. Our next question is, a 5 centimeter tall object is placed 10 centimeter from a concave mirror of focal length 15 centimeter. So the position, nature and the size of the image are option A is minus 15 centimeter real and 15 centimeter direct. The option is option C 30 centimeter virtual and 15 centimeter erect. Our next question is the angle between incident ray and reflected ray is 70 degree. What is the angle of incidence? In reflection, the angle of incidence I, which is equal to the angle of reflection. In this diagram, this blue line shows the incident ray and then red line shows the reflected ray. The angle between the incident ray and then reflected ray is equal to 70. So 2I is equal to 70. I is equal to 70 divided by 2, which means 35 degree. So the angle of incidence I is equal to 35 degree. Our next question is, a man is using concave mirror for shaving. If his face is 20 centimeter from the mirror having magnification 1.5, what will be the focal length of the mirror? The magnification of the mirror M is equal to B by U. U is the distance of the object. V represents the image of the distance of the image. Okay. Then magnification value is 1.5. So 1.5 is equal to minus of V by U. What is U? U, which means distance from the object. In this problem, the man is standing in front of the mirror. If his face is 20 centimeter from the mirror having magnification 1.5. So, U is equal to 20. The man is standing in front of the mirror. So, we are using minus 20. So, V is equal to 30 centimeter. Now we are going to find the focal length of the mirror. What is the formula of focal length of the mirror? Focal length which is equal to 1 by V plus 1 by U. B is equal to 30 centimeter and U is equal to minus 20 centimeter. So the focal length 1 by F is equal to 1 by 30 minus 1 by 20. If you simplify this equation, we got F is equal to minus 60 centimeter. This is the focal length of the mirror. Our next question is, the refractive index of the material of an equidouble convex lens is 1.5. What is its focal length? Radius of curvature, which means R. So the formula is 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. For an equidouble convex lens, R1 is equal to minus of R. So 1 by F is equal to, we are going to substitute the value of mu 1.5 minus 1 into 1 by R minus of 1 by R. It will come in the next step, 1 by R plus 1 by R, 2 by R. So 1 by F is equal to 0.5 into 2 by R is equal to 1 by R. Finally, we got 1 by F is equal to the focal length 1 by F is equal to 1 by R. So the option D is the correct answer. The focal length is equal to R, radius of curvature R. Our next question is, the speed of light in air is 3 into 10 power 8 meters second minus 1. What will be its speed in diamond whose refractive index is 2.4? The formula is B is equal to C by N. C is equal to 3 into 10 power 8 meter second minus 1 divided by refractive index 2.4. So B is equal to 1.25 into 10 power 8 meter per second. Our next question is, the refractive index of water is 4 by 3 and that of glass is 5 by 3. What will be the critical angle of ray of light entering water from glass? We know that the critical angle sin C is equal to 1 by mu. Mu represents the refractive index. Here they has given the two mediums of refractive index is water and glass. So the formula is, critical angle is sin C is equal to mu 1 by mu 2. Mu 1, which means refractive index of water is equal to 4 by 3. Mu 2 is equal to refractive index of glass 5 by 3. Now we are going to substitute these two refractive indexes mu 1 and mu 2 in the above formula. Sin C is equal to mu 1 by mu 2. We got sin C is equal to 4 by 5. So theta is equal to sine inverse of 4 by 5. So the option is sine inverse of 4 by 5, option A. Our next question is, two thin lengths of focal length f1 and f2, which is placed coaxially in contact. The combination acts as a single length of focal length 1 by f is equal to 1 by f1 plus 1 by f2. We can write f2 plus f1 divided by f1 into f2. So the focal length f is equal to f1 into f2 divided by f1 plus f2, option A. Next question is, a ray of light from air is incident in water. Then, which property of light will not change in water? Option A is velocity. Option B is frequency. Option C is amplitude and color. The answer is frequency. Our next question is, a prism has a refracting angle of 60 degree. If it produces a minimum deviation of 30 degree, the angle of incidence is, the angle of incidence I is equal to A into delta by 2. A, which means refracting angle. Refracting angle is equal to 60. Then minimum deviation is equal to 30 degree, which means delta m. Delta m is equal to 30. We need to find out the angle of incidence. So I is equal to A plus delta m divided by 2. A is equal to 60 plus 30 divided by 2. So the angle of incidence I is equal to 45 degree. Our next question is, Kirchhoff junction law is, option A, summation of current is equal to 0. Option B, summation of voltage is equal to 0. Option C, summation of P, power is equal to 0. Then option D, summation of resistance R is equal to 0. Kirchhoff junction law is called as Kirchhoff first law. Kirchhoff first law means Kirchhoff current law. What it's defined? The algebraic sum of the current which is entering into a circuit is equal to the algebraic sum of the current which is leaving from the circuit. So the summation of current I is equal to 0. This is the Kirchhoff first law and Kirchhoff current law. Our next question is, charge 5 microcoulomb moved across 200 voltage of battery. So what will be the work done? We have to find out the work done. W. W is equal to Q into V. QV. Q represents the charge, V represents the voltage. So work done W is equal to 5 microcoulomb. We can write 5 into 10 power minus 6 into 200. So work done W is equal to 10 power minus 3 joule. In an astronomical telescope, the focal length of the objective is made half of the eyepiece, and option B is equal to the eyepiece, and option C is shorter than that of the eyepiece, and then fourth option is greater than that of the eyepiece. In an astronomical telescope, the focal length of the objective is made greater than that of the eyepiece. The objectives with large apertures are used in the telescope for bright image. Our next question is, two identical spheres, it has a capacitance C, are at potentials P plus V and minus V. They are connected by a wire. Now we are going to find out the loss of energy. The formula of the energy E is equal to half CV square. C represents the capacitance of the wire and V, which means voltage of the wire. Half CV square is equal to E. Our next question is, energy stored in capacitor C is equal to 2 microfarad. We can write 2 into 10 power minus 6 farad. Then V is equal to 100 volt. We need to find out the energy stored in capacitor. The formula of energy E is equal to half CV square. So E is equal to 1 by 2 into 2 into 10 power minus 6 divided by half CV square into 100 into 100. Finally, we got the answer 0.01 joule. Our next question is, a double slit interference experiment is carried out in air and the entire arrangement is dipped in water. The fringe width is increases or decreases, remains unchanged, or fringe pattern disappears. The answer is the fringe width is decreases. The amplitude ratio of two superposing waves is 2 is to 1. The ratio of maximum and minimum intensities is the formula of the maximum and minimum intensity, which is given by I max by I minimum is equal to A plus B whole square divided by A minus B whole square. Here A is equal to 2 and B is equal to 1. We can write 2 plus 1 whole square divided by 2 minus 1 whole square. 2 plus 1, which means 3. So 3 square is equal to 9 divided by 2 minus 1, which means 1. 1 square is equal to 1. So the answer is 9 by 1. 9 is to 1. The ratio of maximum and minimum intensities is 9 is to 1. Next question is relative permeability is mu r is equal to mu by mu naught. The relative permeability is defined as the ratio between the permittivity in free space and vacuum. Mu r is equal to mu by mu naught. Our next question is the bending of beam of light around the corners of obstacles is called diffraction. Next question. A deuteron moving with velocity 2v and an alpha particle moving with velocity v. What is the ratio of de Broglie wavelength associated with it? Let m be the mass of a proton or neutron. Deuteron is a particle having one proton and one neutron. Therefore, mass of deuteron, which is equal to twice the mass of proton or neutron to m. Alpha particle is a particle which is having two protons and two neutrons. Therefore, mass of alpha particle is equal to 4 times the mass of nucleon is equal to 4m. According to de Broglie wavelength associated with the neutron moving with velocity 2v is lambda 1 is equal to 4mv, lambda 2 is equal to 4mv. So the answer is 1 is to 1. The de Broglie wavelength associated with a small particle changes by 0.25 percentage. If its momentum is changed by P naught, the initial momentum was dash. We need to find out the initial momentum. What will be the initial momentum? The initial momentum we just consider as P, and then change in momentum we just consider as P naught. The de Broglie wavelength lambda is equal to 0.25 percentage. We can write 0.25 divided by 100 percentage, which means 1 by 100. So 0.25 divided by 100. The formula of de Broglie wavelength lambda is equal to P naught by P. P naught is equal to change in momentum. P is the initial momentum. So from this equation we can find P is equal to P naught by lambda. So P is equal to P naught divided by 0.0025. 0.25 divided by 100 we can write 0.0025. So the answer is P is equal to 400 P naught. Our next question is if B is frequency, nu is the frequency. Lambda is the wavelength. Nu bar is the wave number. Then the energy of a photon can be represented by the photon energy E is equal to h nu. H means Planck's constant. E represents the energy of a photon. Then E is equal to h nu. Nu means frequency. Nu is equal to C by lambda. C represents the intensity of light and lambda represents the wavelength. So E is equal to hc by lambda. 1 by lambda is equal to nu bar. So the final answer is hc nu bar. Next question is, in a sample of radioactive substance, what percentage decays in one mean lifetime? T is equal to tau 1 by lambda. So the formula of one mean lifetime is equal to n by n naught equal to e power minus lambda t. E power minus 1. The value of 1 by e is equal to 0.36. Now we are going to find the mean lifetime. 1 minus 0.36 is equal to 0.64. We can write 0.64 divided by 100. So 64 percentage. The option is B, 63.2 percentage. Our next question is, the three capacitors each of capacity 4 microfarad, which is connected in such a way that the effective capacitance is 6 microfarad. This can be done by connecting all of them in series. This is option A. And option B is connecting all of them in parallel. And option C is connecting 2 in series and 1 in parallel. And option D is connecting 2 in parallel and 1 in series. If we are connecting 3 capacitors in series connection means the equivalent capacitance is equal to 1 by Cs is equal to 1 by 4 plus 1 by 4 plus 1 by 4, which is not equal to 6. So we can go for the next option, connecting all of them in parallel. If we are connecting these three capacitance in parallel means the effective capacitance 1 by Cp is equal to C1 plus C2 plus C3. 4 plus 4 plus 4. So 12, which is not equal to effective capacitance is 6. So this is not the answer. Now we are going to the third option. If we are connecting the two capacitors in series connection and one capacitor in parallel connection, first we are going to find out the equivalent capacitance in series. Cs is equal to 1 by 4 plus 1 by 4 is equal to 2 by 4, which is equal to 1 by 2. Then this system is connected with the one more parallel capacitance. So this 1 by 4 plus we can write the equivalent capacitance Cp is equal to 4. Then third capacitor is connected in the parallel. So the option is connecting two capacitors in series and one in parallel. The next question is, the bulbs and B are connected as shown in the figure. If the bulbs B and C are identical, B and C are identical. If the bulb C is fused, what will happen? When C gets fused, the overall resistance of the circuit is increases when the current A gets reduced, due to which it gets dimmer. Also, the current passing through the bulb B, which glows more brightly. So the answer is the bulb A will glow less brightly and B will glow more brightly, because when C bulb is fused, the overall resistance of the circuit is increases and the current A is reduced. Our next question is, what is the majority charge carrier in P-type semiconductor? First of all, you want to know about the semiconductor. What is semiconductor? Materials can be classified into three types based on the valence band and conduction band gap, that is called as band gap energy. Based on the band gap energy, materials can be classified into three types, which is conductors, insulators, and semiconductors. If the band gap energy, the valence band gap and the conduction band gap is more, which is called as conductors. If the band gap energy is medium between the valence band and conduction band is semiconductors. And then there is no band gap energy, the valence band and conduction band both are overlapped, which means insulators. In the p-type semiconductors, the majority charge carriers are holes. Next, what is the majority charge carrier in n-type semiconductors? In n-type semiconductors, the majority charge carriers are electrons. Electrons and holes both are called as charge carriers in the semiconductor. Next question. In a certain circuit, the transistor has a collector current of 25 microampere milliampere and base current of 65 microampere. What is the current gain of the transistor? The current gain formula is current gain is equal to IC divided by IB. IC, which means collector current and base current. The ratio between the collector current and base current is called as current gain. So the current gain of the transistor is equal to 25 into 10 power minus 3 divided by 65 into 10 power minus 6. The answer is 384.61. This is the current gain of the transistor. Our next question is, which of the following logic gate is a universal gate? We know that NOR gate and NAND gate are called as universal gate because it can connect with any logic gates. The basic logic gates are AND gate, OR gate, and NOT gates. These are the basic logic gates, and universal logic gates are NOR gate and NAND gate. Next question is, a transistor is operated in a common emitter configuration at V is equal to 2 volt, such that a change in the base current from 100 microampere to 200 microampere produces a change in the collector current from 5 milliampere to 10 milliampere. So the current gain is equal to beta is equal to delta IC. What is delta IC? IC means current, collector current. What is delta IC means change in collector current divided by delta IB. IB which means base current. Delta IB means change in base current. So change in collector current is equal to 10 minus 5. So 5 milliampere. Change in base current which means 200 minus 100 is equal to 100 milliampere. We can solve beta is equal to 5 into 10 power minus 3 divided by delta IB value is 100 into 10 power minus 6. So the answer is 50. Lenz's law is a consequence of the law of conservation of energy. Our next question is light of wavelength 4000 is incident on a metal whose work function is 2 electron volt. The maximum kinetic energy of emitted photoelectrons is 1.1 electron volt. So the formula is kinetic energy E is equal to h nu minus work W. H nu is the energy of photon absorbed in the metal. So E is equal to H. Nu is nothing but C by lambda. So the answer is 1.1 electron volt. If H is a Planck's constant, the momentum of photon of wavelength 0.01 is option D, H into 10 power 12. Our next question is 3 charges each of plus 1 microcoulomb, which is placed at the corners of an equilateral triangle. If the force between two charges is F, what is the net force on each charge? The formula F is equal to root of F square plus 2F square into cos theta. Here theta is equal to 60 degree because the triangle is an equilateral triangle. So theta is equal to 60 degree. Cos 60 degree is equal to 1 by 2. So F is equal to F square plus F square plus F square root of 3F square. We can take F from the root outside. The net force is equal to root 3F. The option is C, root 3F. Our next question is, in photoelectric effect, the photoelectric current is increased with increase of frequency of incident photon. If EA be the electric field strength due to a short dipole on the axial line and EE that on the equatorial line at the same distance from the center of dipole, then the axial field EA is equal to 1 by 4 pi epsilon naught 2p by r cube. Then the equatorial field EE is equal to 1 by 4 pi epsilon naught p by r cube. So the relationship between the axial field and then equatorial field EA is equal to 2, EE is equal to 1. So EA by E is equal to 2 by 1. The answer is EA is equal to 2 into EE. A photon of energy 8 electron volt, which is incident on a metal surface of threshold frequency 1.6 into 10 power 15 Hz. The kinetic energy of emitted photoelectrons is the kinetic energy of the photoelectron is equal to h nu minus h nu naught, which is equal to 8 electron volt. Kinetic energy is equal to 8 electron volt minus 6 into 10 power minus 34 into 1 power 6 into 10 power 15 divided by 1.6 into 10 power minus 19. If we sort out this equation, we got the final answer 2 electron volt. A metal with work function of 0.6 electron volt which is illuminated with a light of 2 electron volt. What is the stopping potential? The stopping potential we can represent as V naught. The formula of stopping potential V naught is equal to E minus pi naught by E. The value of E is given in the problem 2 into 10 power 6 into 10 power minus 19 minus of pi naught 0.6 into 0.6 divided by E 1.6 into 10 power minus 19. So the value of stopping potential is 1.4 volt. The next question is work functions of tungsten and sodium are 4.4 electron volt and 2.3 electron volt. The work functions we can represent as pi naught. Work functions of tungsten, which means pi W is equal to 4.4 electron volt. Work function of sodium is equal to pi Na is equal to 2.3 electron volt. If threshold wavelength of sodium is 5460, the wavelength of sodium is equal to lambda is equal to 5460, then what is the threshold wavelength of tungsten? The relation between the work function and the threshold wavelength is pi is equal to h nu. Nu is equal to c by lambda. So we can write pi is equal to h by lambda. From this equation, we can find the wavelength. Lambda is equal to 1 by pi. So lambda is inversely proportional to the pi. Pi means work function. So lambda W divided by lambda sodium Na is equal to pi. Both are in inversely proportional. Pi Na divided by pi W. The answer is 2856. This is the threshold wavelength of tungsten. The light of wavelength 4000 is incident on a sodium surface for which the threshold wavelength of photoelectrons is 5420. What will be the work function of sodium? The same formula pi naught is equal to hc by E lambda naught. H is the Planck's constant. The Planck's constant value is 6.62 into 10 power minus 34 into C is the intensity of light 3 into 10 power 8 divided by lambda wavelength 5420 into 10 power minus 10. Then the value of E is equal to 1.6 into 10 power minus 19. So the work function of the sodium is 2.29 electron volt. Our next question is maximum velocity of photoelectrons emitted is 4.8 meter second minus 1 if E by M ratio of electron is 1.76 into 10 power 11 coulomb kilogram minus 1. What is the stopping potential is given by E V naught is equal to half mv square. From this equation, we can find the value of velocity stopping potential V naught is equal to 1 by 2 m by E V square. We know the value of E by M. We just convert it and substitute in this equation 1 by 1.76 into 10 power 11. So the answer is 7 into 10 power minus 11 joule per coulomb. The de Broglie wavelength of 10 kilovolt electron is The standard formula of electrons de Broglie wavelength lambda is equal to 12.27 divided by root of V. Here they has given 10 kilovolt. So we can convert as volt 10 into 1000. So 10,000. 12.27 divided by root of 10,000. We can take this 10,000 from root outside 100. So 12.27 into 10 power minus 2 Armstrong. An electric current of 10 ampere flows in a wire for hour. Amount of total charge which is passed through a given cross section of the wire. We need to find out the charge. Q is equal to IT, the product of current and time. The current that is given I is equal to 10 ampere and time t is equal to 1 hour. So t is equal to 3600 seconds, 60 minutes. So we can convert as seconds, 3600 seconds. So Q is equal to 10 into 3600. So the answer is 36,000 coulomb. The next question is, the de Broglie wavelength of electron is 1. The velocity of electron is 7.3 into 10 power 6 meter second minus 1. The use of de Broglie wavelength relation lambda is equal to h by p. H is the Planck's constant, p is the momentum. Momentum is nothing but the product of the mass and then velocity. P is equal to mv. From this equation, we can find V is equal to h by m lambda. The Planck's constant value is 6.62 into 10 power minus 34 divided by mass of the electron is equal to 9.1 into 10 power minus 31 into lambda 1. The de Broglie wavelength of electron is 1. So we can write here 1 into 10 power minus 3. So the answer is 7.3 into 10 power 6 meter per second. The next question is, light of wavelength 4000 is incident on a sodium surface for which the threshold wavelength of photoelectrons is 5420. The work function of sodium is equal to pi naught is equal to hc by e lambda naught. H is the Planck's constant value 6.62 into 10 power minus 34, and then C value intensity of light 3 into 10 power 8 divided by lambda 5420 into 10 power minus 10 into electron 1.6 into 10 power minus 19. If you substitute these values and simplify, we get the answer 2.29 electron volt. This is the work function of sodium is 2.29 electron volt. The refractive index of water is 4.3 and that of glass is 5.3. What will be the critical angle? The critical angle sin C is equal to 1 by mu. Mu is the refractive index. Here they has given the two refractive indexes of medium. One is water, another one is glass. So we can consider mu1 is equal to refractive index of water, which is equal to 4 by 3. Then mu2 is the refractive index of glass. Mu2 is equal to 5 by 3. Now we are going to find out the ratio between mu1 and mu2. Sin C is equal to 4 by 3 divided by 5 by 3. So sin C is equal to 4 by 5. C is equal to sine inverse of 4 by 5. This is the answer. So the critical angle of ray of light which is entering water from glass is sine inverse of 4 by 5. This is the answer.
Yeah, thank you very much, madam.
Thank you.
Thank you, madam.